We have a double integral to calculate. It's the integrand is e to the x squared. So we have no chance of finding the antiderivative in terms of x first. So we have to then change it to dy dx. Let's check out and see what the region is. We have x equals y minus 2 all over 2 as a lower limit. That's a line. That's 2x is y minus 2. So that y is equal to 2x plus 2. That's the line. Slope of 2, y-intercept of 2. That is the low end on x. The upper limit on x is 1. And so we have the line y equals y equals 2x plus 2. Should look something like this. More or less. And the line x equals 1 looks like that. And they are intersecting here at the point 2, 4, intersecting there. Y's go from 2 to 4. So if we were to zoom in, we'd see that the region that we're talking about is this triangular region here. Where we're first doing it as dx dy, and then we're switching it to dy dx. As dx dy, we have rectangles that are horizontal, and we move them vertically. As dy dx, we're going to have rectangles that are vertical, and we move them horizontally. And so then the low end on the inner limit will be 2. The high end on the inner limit will be the line. We'll have the inner limit of integration would be from y equals 2 to the line, y equals 2x plus 2. And then we move that from x equals 0 to x equals 1. The integrand dictated to us that we needed to change it to be dy dx because we couldn't find the antiderivative with respect to x first. Now with y, it's supposed to help us out. Let's see. So we put in, this is just the antiderivative is just e to the x squared times y. And y is evaluated from 2 up to 2x plus 2. So we're going to have the integral from 0 to 1, 2x plus 2 times e to the x squared. Watch this, conveniently, minus 2e to the x squared. because if it was just still there, we still wouldn't have any way to, if you had the e to the x squared term still there, we still wouldn't have a way to find the antiderivative. But conveniently, those two cancel each other out. The 2e to the x squared and the minus 2e to the x squared cancel, and so we're just integrating um, 2x e to the x squared. Let me pull the 2 out. Oh, you know what? Leave it in there. I'm sorry. It's even better. 2x e to the x squared. So that, yeah, it's just a quick U substitution shows you that, or mentally do it, where the derivative of x squared is 2x. And so if u is the entire x squared, then du is 2x dx. And your integral then is just e to the u du, which is e to the u as the antiderivative. So we get the antiderivative of this is just e to the x squared, evaluated from 0 to 1. We get e to the 1 minus e to the 0. Final answer of e minus 1. And we had to switch limits of integration in order to be able to do that.